Hey guys, this is Amitesh from Liquid Instruments. Down here in the lab today, we're going to show you how to lock laser with our 12th newest instrument, the laser lock box. So here we are using the 1064 NGA laser going through the EOM right here, and then we have the optical setup over here going into the high finesse cavity. We use the reflected signal to lock our laser. Connecting the Moku is straightforward. Input 1 is used as the main channel for most of signal processing. Connect the AC signal from the diode receiving the reflected signal here. Connect the DC output from the diode receiving the transmitted signal, input 2. Although not necessary, the DC signal helps identify and optimize features in the locking system. In this experiment, 20% of the transmitted signal is routed to a camera which shows the beam on a computer screen. The modulation signal is sent to the EOM to produce phase modulation sidebands. The primary error signal is, in this case, fed back to the PZT frequency control of the laser through a high voltage amplifier. An optional secondary feedback signal can be used to feedback to the thermal controls of the laser. Temperature feedback generally has greater range, but it is slower. The connections are summarized in this diagram, which is also in our app note on the website. Now select the Laser Lockbox app, follow the settings in the app note, which is on our website, and scan the laser frequency, which helps characterize and optimize signals for locking. Here you see the reflected signal in red. We use that to create our error signal in blue, and you can change the phase of the error signal simply by sliding left, right, or left. As you can see here, it is unlocked. We are scanning over the transmitted and the error signal. To tap the laser, there's a tap to lock button, and you can tap anywhere we choose to tap on the resonance. And now the laser is locked. For more details, please see our Laser Lockbox app note on our website. Thank you.